Hello everyone, welcome for this lecture. Today we are going to discuss the star delta transformation technique. In that star delta transformation, we have star to delta transformation to convert star into delta, and we have another one delta to star. Okay, so to discuss with this, we have a set of formulas, and we have discussed this in earlier semester also. Let's glance once and then we can start using those. Okay, first one will take a star to delta. Okay, star connection, you can observe here you will be having A, B, C, and in between those resistances star connected resistances. Okay, this is RA, RB and RC. So this we supposed to convert, okay, to a delta connection, which will be in the form of delta, which has A, B, C. So these forms are remains the same, A to A, B to B and C to C. Only resistance will be in the form of a star here, and it will be delta here. Okay, so to convert that we are using star to delta. There we need to calculate RAB. To calculate RAB, we are going to use RA, RB and RC resistors. Okay, let's calculate RAB. That one can be get by RA plus RB plus RA into RB divided by RC. Okay, make a practice so that we can remember easily. Next is RBC. So to calculate RBC, we have RB plus RC plus RB into RC divided by RA. Okay, similarly RAC also. Okay, RA plus RC plus RARC divided by RB. Okay, so then next we have delta to star connection. Now suppose if we have a delta connected network, then how we need to convert this into a star connected network. Observe here we know AB, that is RAB, RAC and RBC. We supposed to calculate RA, RB, RC. Okay, to calculate this RA, that should be equal to, RA should be equal to what and all you know in with respect to this A, that we have to substitute. So RA will be equal to RAB into RAC divided by all the resistances, that is RAB, RAC, RBC. Okay, and RB is equal to which forms from B and which connects from B, that we have to take. RB is equal to RBA or RAB and R into RBC divided by total resistance. Okay, common, you can observe the in the common thing is denominator is same for all the resistances. Okay, when you are going to convert delta to star. Okay, so RC will be equal to RAC into RBC divided by RAB plus RAC plus RBC. Okay, so let's use this technique and let's solve the numerical. Let's take an example. That is, they have asked us to find the resistance between A and B. Remember this, they have asked us to calculate the resistance between the A terminal and B terminal. Okay, this should not alter, right, for network shown below using star delta transformation. Okay, observe this network, how we can calculate the, observe, in this we need to calculate the resistance between A and B terminal. You can take a wire between these two. Okay, how can we calculate it? So observe the network entire keenly. So this inside, okay, inside that network, if instead of the star, if it was a delta, okay, it is what easy for us, because observe, I'll solve just a skeleton. Let's take a skeleton of this like this. So this will be outer side, right? It will be A, B, C. So whatever we have inside, that is a star connection. So if we convert that, we will get a delta connection like this. Okay, and then so then these two resistances and these two resistances and these two resistance are in parallel. So can we get its equivalent network as a simple network, that is a simple delta connection, correct? You have to mention their names as it is A, B and C. Now they have asked us the equivalent resistance between terminal A and B. So what happens there is these two resistance, this one and this one, C we have to neglect that time because we require between A and B. Okay, that C will not be there, will not be considered. So this resistance and these two resistances are in series. So add these two, you get one simple resistance, and here one resistance between A and B. How these two resistance are in parallel, so you get single resistance, that is equivalent resistance between the terminal A and B. I hope you have got how to tackle this, right? Let's calculate. How to take this is, let's consider inside star connection, that is 5 ohm, 7 ohm, 6 ohm. Okay, this is 5 ohm is RA, 7 ohm is RB. Okay, it is RA, RB, and it is a RC. Okay, we need to convert this into a delta connection, A, B, C as it is, A, B and C as it is. Okay, let's take RAB. RAB equal to, as we know the formula, RA plus RB plus RARB divided by RC. Substitute the values. RA is 5 ohm plus RB is 7 ohm plus RARB means 5 into 7 divided by RC, which is not there, that is divided by, so 6 ohm. So if you do this, you will get 17.8 ohms. Okay, similarly you calculate RBC. You know the formula, RB plus RC plus RB into RC divided by RA. Similarly, substitute the value, you get 21.4 ohms. As it is, in the same way, you can calculate RAC as well. Okay, once you got all the values, substitute in this. RAB is how much? It is 17.8, and RBC is 21.4, and then this one is 15.28 ohms. Okay, and then this one, let's substitute, means let's insert this delta in the main circuit, replacing star connection. You get like this, right? Observe, this will, star was there inside, now it will be delta connected. So you can observe these two resistances, that is 2 ohm and 15 ohm, 15.28 ohm will be in parallel, 21.4 and 4 ohm are in parallel, and these two are in parallel. So let's use a formula. What is RAB? Means I'm just taking like this, RAB is equal to equivalent resistance where these two are in parallel. So 3 into 17.8 divided by 3 plus 17.8. Similarly, we can do for RBC and we can do it for RAC. Okay, you know two resistance which are parallel, you can take R1 into R2 divided by R1 plus R2 formula. By that, if you calculate, you get this equivalent is, parallel equivalent is 2.5607 ohm, and then this one is 3.37, and this one is 1.768. Okay, calculate and let's see the answers. Okay, then what you have to do is, this is your equivalent, as it means right now after simplifying you got the circuit diagram. Okay, this is your network. Now it is a delta form, don't convert it into star because we require between A and B. Observe these two resistances. Okay, observe these two resistances, that is 1.7 and 3.7 are in parallel, sorry, in series. So these two are in series, right? These two are in series. So let it be A and B terminal as it is. Okay, this is A and this is B as it is. So 2.567 ohm will be here, and these two 1.768 plus 3.37 addition of these two, because these two are in series. Okay, these two are in series. So add this one, you will get a 5.138. So once you get this combination, we require between AB. Okay, these two are in parallel. Take that combination by taking R1 into R2 divided by R1 plus R2, that is 2.567 into 5.138 divided by addition of these two, 2.567 plus 5.138, which you get 1.7. That is your equivalent resistance between the terminal A and B. Okay, hope it is clear, right? We'll see the next one. same kind of numerical. Okay, so there they have asked us to calculate, find the equivalent resistance between X and Y terminal. Remember, all resistors are in ohm. Okay, so between X and Y we have to calculate. Let's roughly do it once and then we can do it systematically. Okay, in this, between this X and Y there is a 100 ohm resistance. Let it be as it is. Okay, upper part you come this point. I'll mention this as A, B and C. Okay, for a time being. So observe observe this. So whatever 40 ohm is there, it will be like this, and 60 ohm. So whatever this is there, 12, 20, 20 ohm, those are all star connected. Am I right? Those three are star connected. If you convert that star into a delta, you get a circuit like this. Right? Circuit like this. Barabar. So now we can say these two resistance are in parallel, these two resistance are in parallel. Okay, keep as it is. Right? When you keep these two resistances in a parallel, and then afterwards what happens is your equivalent circuit becomes, and so after converting it will be like this. Right? Okay, this is 100 and this is calculated value, and this is also your calculated value. How these two will be in series? These two will be in series. You can take that, and this resistance, and this is a 100 ohm resistance. Okay, by taking these three, you can take X and Y. How these three are? These three are in parallel. So again, what you can say, take equivalent to parallel combination resistance you can take. That will be your resistance between, equivalent resistance between X and Y terminal. Okay, let's see that. So in this network, let's take first one, that is a star connected, and then convert that into a delta. 12, 20, 20. Okay, let's name it A, B and C. So let's name A, B, C as it is. So RAB we require, RBC and RAC. Let's calculate that. RAB equal to RA plus RB plus RARB divided by RC. As you know the formula, substitute the values also. RA, RB and RC. RA plus RB plus 12 into 20 divided by 20. It will be 44. So like this you calculate RBC and RAC. Once you got all the values, substitute in this. Okay. So let's substitute that value, and whatever delta we have, let's insert in this circuit instead of this star connection. Okay, once you do that, we get, observe, outside was 40 ohm and 60 ohm and 100 ohm was that, right? So this is 73.33 ohm, 44 ohm and 44 ohm. These three are in delta connected. Okay, now we'll convert this. So okay, so let's take and so between C and B we'll be taking, there is a 73.33, and then 40 and 44 are in parallel. Take a parallel combination, and then 60 and 44 are again in a parallel. To take that also in a parallel combination, single resistance, and then this is your X and Y. Okay, this is your X and Y. Okay, this is your 100 ohm. Right? So after this, these two will become in series. This one 73.33 will be here, and then 100 ohm will be here. This is between X and Y, right? In the same way, let's see. So once you have taken its combination, it is 20.95, and this one is 25.38 parallel equivalent resistance. Okay, parallel combination resistance 73.33 and 100 ohm. Okay, next go through the calculations once, and after this, these two 20.95 plus 25.38 are in series, therefore we are supposed to add. Okay, and then 73.33 and 100 ohm. Okay, so once you have seen this, once you have got this circuit or network, what you have to do is observe this network. These three resistance are in parallel. So you're supposed to take equivalent of that. 2, if you have a 2 only, you would have calculated by taking R1 into R2 divided by R1 plus R2, right? But when you have more than 2, you cannot use that formula. What you have to do is equivalent resistance will be 1 by Rxy is equal to 1 divided by first resistance, second 1 plus 1 divided by second resistance, and third resistance. Take its equivalent, take its inverse. This is your equivalent resistance between the terminal X and Y. Okay, I hope you have understood this. Thank you.